So, welcome back, guys. What we got for you today is section 2.5, segment lengths in circles. Really important to note, this entire section is just theorems. So, these theorems will be provided for you, whether they're on the test or I'll have a formula sheet. You will have them with you, okay? So, it's all about segment lengths in circles. Here we go. If two chords intersect in the interior of a circle, and the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Real simple. You can take a piece, okay, EA times EB, and you can make that equal to a little piece, CE, times the other little piece, ED. Simple as can be, right? So find the value of x, round all decimals nearest tenth. I'm taking a piece on each line, so x and 10 are on the same line. So we're going to do 10 times x, and we're going to make that equal to 5 times 8, just piece and piece. Okay, so 10x equals 40. There's an 8 there before someone asks. Divide both sides by 10. X equals 4. Okay, so if we look over here to the right, what piece is on which piece? 4 and x, and 3 and 8. All right, so 4x equals 3 times 8. 4x equals 24. Divide both sides by 4. X equals 6. Okay. I like these problems. They're like little crisscross path problems. They're not too bad. Nothing too crazy. Pretty simple, and the answers normally turn out pretty nice. Okay. All right. For our next part, this is basically the same theorem. You'll notice it just looks a little different for each one. Let me just explain over here what we're talking about. If I have a line cutting through my circle going to the outside, what you can do is you can say EA, this little piece right here, times EB, the whole length, is equal to EC, this little piece, times the whole length, ED. Alright? So little piece, whole thing. Little piece, whole thing. This is the same thing, except please note that this is a secant cutting through it and this is a tangent. So when we do the EC part, it's EC times ED, just like up here. But for the EA, all we're going to do is this times itself. EA squared. EA times EA. It's in the game. Any gamer out there. Sorry. But let's take a look at some of these in action. Okay. I am going to save this one to A till the end. This, I believe, if I'm not mistaken, is a challenge problem, which I will show you then. It's really, really nice, but I want to make sure you hit everything else, which I'm going to definitely have you guys be known to do. Okay. So for part B, number 2, part B, we're doing small piece, 9, times the whole piece. Now, this is where it gets a little tricky. If you're thinking it's 9x, it's a very good thought. But we have to add these together, this plus this. So it's x plus 9. And that equals my outside squared. So 15 squared. And now we just solve, okay? But again, just real quick recap. Little piece on the outside times the full thing. The full length is x plus 9 equals 15 squared. Multiply the 9 in. 9x plus 81 equals 225. Okay. Got kind of dim in here, but 225 minus 81 gives me 144. So I get 9x equals 144. I can do that divided by 9. X equals 16. Alright? Very good. Let's take a look at our next one down here. Okay, I will get back to this one. Don't worry. I know you're probably worried like, oh, Mr. Howard, we want to know this one. Hold your horses. It'll be good. Down here, this is the 2 secant one. So it's little piece on the outside times the full length. So 12 times x plus 12. I just like, if you put 12 plus x, you're fine. I like putting the x first. It's just a creature of habit. That's how I do things. Equals 15 times, it's the whole length, 15 plus 9. Alright, so I'm going to clean this up a little bit. Let's see here, 12x plus 144 equals 15 times 24. 15 times 24 gives me 360. Appropriate, since we're talking about circles. Subtract 144 from that. So minus 144. 12x equals 216 divided by 12, x equals 18. We're all good. All right. Excellent. So this next one might also be a challenge one, but I'm going to show it to you anyway. All right, so let's take a look at it. What we've got here is little times big, so x times, if I add these together, it's x plus 3x equals little 8 times all this add together, 8 plus x plus 2. Okay, over to the left, I can multiply the x in. X squared plus 3x squared. Over here, I can combine like terms first. 8, 10 plus x. All right, combine those two together, I get 4x squared equals 80 plus 8x. Now I'm going to get everything equal to 0. I'm going to move this over. Subtract over the 8x, subtract over the 80. I get 4x squared minus 8x minus 80 equals 0. All right. Now, please hang with me. I'm going to divide everything by 4 because there's a common term there, GCF of 4. So x squared minus 2x minus 20 equals 0. Okay. Now, you would think to factor here, all right? In this case, we're not going to be able to factor. So this is actually going to be a quadratic formula problem, okay? Now, I'm going to show you this. Please put a little star next to this. I am not, for the sake of this test, going to give you a problem like this, all right? This will not happen on your test. Let me make this very clear to you. This is a good problem. It's good that you see it. You've probably seen it before, but here we go. Here's your A, here's your B, here's your C. This is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Quadratic formula. Okay? I'm just plugging things in. Negative of negative b, negative negative 2, plus or minus my negative 2 squared, minus 4, my a is 1, my c is negative 20. Divided by 2 times 1. So I got 2 plus or minus, all that junk inside there, I can put it all right in here. Negative 2 squared, minus 4, and then my c is negative 20, so 84. Okay. The very last thing we have to do here is, we're going to do 2 plus square root of 84, okay, and divide that by 2. Gives me 5.58. And then the other one is, see how we have plus or minus here? Instead of doing 2 plus 84, I'm going to do 2 minus 84, square root of 84, divided by 2. So we get negative 3.58. Alright, now, one quick question for you. One of these answers is not going to work, okay? And if we look up top here, x is on the outside. Please note, we can't have a negative. Alright, so we would cross this off. Let me just say again, this will not be on a test or a quiz. I wanted to share that with you because I thought it would be beneficial. This is something you will do next year, okay? But the earlier I can get you exposed to it, the better. Alright, let's finish up with these last two problems here. Outside 6 times the entire thing, 6 plus x plus 3, equals outside x times the whole thing, x plus 4x. So we got 6, 9 plus x equals 5x. I can distribute the 6 in. 54 plus 6x equals 5x squared. Move everything over. So 0 equals 5x squared minus 6x minus 54. Again, this problem, again, just to show you, you would then go back to your quadratic formula. I'm not making you do that. If you can get to here, if you can get to this spot, that's a wonderful place to be. Anybody wants to try this out, you let me know. You try it, and I'll show you how to do that, okay? Finally, little piece times little piece times little piece. We got x minus 2 times x plus 7 equals 4 times 2x minus 1. FOIL this out. It's good that you guys see this. X squared plus 7x minus 2x minus 14 equals 8x minus 4. Get everything on one side. Oops. Hold on a second. Subtract 8x, subtract 8x. That's not good. Okay, and then if I add the 4 over, I got minus 10. Now to show you guys this one real quick, alright, this one you can factor. We talked about this in class here today for algebra review. What two numbers multiply to give you negative 10 but add to negative 3? Looking at negative 5 and positive 2. So we could do this, x minus 5, x plus 2 equals 0. Then we can set both of these equal to 0. Okay, and solve. So if I add 5 over, I get x equals 5. If I subtract 2 over, x equals negative 2. Now, again, which one do you think will work? Alright, if I plug in a negative 2 up here, it will make some of these things 0, which won't work at all. So we don't want the negative 2 one. You put a little x through it, it'd be good. So the x equals 5 is the one we want. So please hear me out for a minute, because I just want to make sure that we're very clear on this. Alright, I know, like I said earlier, that this chapter in general is a little bit tougher. If I give you any problems along these lines, they will look like this. They will look like this. Okay? And the absolute hardest one I can throw at you is something like this, where you can factor, because we just covered that. But, and you'll also see something like this. These two, which are really nice. Okay? This problem right here, as well as this problem down here, the ones that use quadratic formula, I am not expecting you guys to know this at this point.